Slow. That's the noise that we're expecting for a long time. Hello from OGS Mechanics and OGS Hybrid and EV Workshop. We are back after a long break. We've done a lot of changes in the workshop and we're gonna bring more and more interesting jobs for you to see, to explain, and to see how exactly we're gonna fix them. And today we've got a Mercedes EQC 400 with a problem on the high voltage system, of course. The car drives, however, there is a warning light on the dash complaining of an issue with the high voltage battery. And what we get from the customer is that is an auction purchase which was running okay for a bit, not precisely how long because it's a company car and shared between drivers, and then eventually someone noticed the warning light on the dash and the range that is not correct. Now this is the time to drive the car in the workshop and start checking to see exactly what's wrong with this EQC. Follow me. Hello from OGS Mechanics. I'm George, and here we fix cars, all types of cars, electric, hybrid, combustion engine cars. Have a look around and follow me for interesting repairs translated in videos. What is noticeable straight away when getting into the car and turning the ignition on, while the ready comes on, there is the malfunction sign, and also still 22-mile range, but there is a warning light, reserve level charge, high voltage battery. So, to understand how we're going to move forward, first of all, we're going to run a diagnostics test to see exactly why the warning light comes on, and then we make a plan of action. Let's get on. Being an auction car is a question mark on the history because there's not much known about it. Let's see what we're going to reveal on our diagnostic test, and more important for us is to see on the high voltage system. So let's see, so far 3 error codes, and until this completes, looking under the bonnet to inspect for a possible accident damage. Everything looks straight in the front, nothing really looks like has been touched. So far this is something that we rule out as being accident damaged vehicle. So let's get on and see what exactly we have in here. Okay, so not too many error codes, but what I'll probably insist on okay, so what I will insist on, we have some error codes for the battery management system and system 2 and system 1. It looks like might be something in the high voltage battery. Lal, I think we have a new challenge if you missed the work behind the camera, behind this other part of the camera. So have a look in here. Voltage of high voltage battery B is implausible. The cell voltage in the high voltage battery are different. This is something that is not right. High voltage battery, they have to be well balanced. Can we get on to the high voltage battery to read the data? Is important. And what is something different on this one, it says there are 2 batteries. We have not yet worked on a EQC first, and we're quite keen to have it up on the ramp to see the setup of the battery. But before that, we're gonna look at the stats that we get of the battery, and it looks like it's gonna be a high voltage battery issue. Let's see what else we can extract out of it.
Battery pack EVA.
So indeed, it has 2 BMS.
2 BMS.
2 BMS.
A and B.
It's interesting. So this one, this is which one, the A?
A.
So this looks very good. Okay, EV1, exactly. This looks very good. Those are the stats that we're looking at. This is a very important state of health and the pack difference, very good. Let's get to the pack 2. Okay, pack 2 still look very good. The balance and state of health. State of charge is here 89. How much is the other one?
25.
Okay, so in here there's a big difference. The state of charge between the two packs, significant difference. So while this one it has 89, the other one is 29. So the pack 2 is the state of charge is significantly more than the pack 1. And when we look at the error codes, the electric fuse has a malfunction in the system too. Yeah, so what this tells me is like, it's like the battery 2, it has power in it, it's not getting used because of a fuse. Yeah. Okay. Well, this is what it looks according to Diagnostics. The next plan is let's have the car on the ramp to see the setup of the battery, and then we'll decide how we're gonna navigate this issue. Let's have the car up. Lift it more. Okay, so this is the underneath of the EQC 400 Mercedes, and initial inspection, battery, all one big stuff, and in here, what do we have here? Must have been hit something, no? It's missing part of the under tray, but here is just the electric motor. No, oh, look, there's a bit of damage to the battery. Okay. So in here, there's a bit of damage to the battery. Doesn't seem that bad, but something has scraped. Those battery casing, they are very, very strong. So in order to put a dent, it must be a bit of an impact. Anyway, no signs of big damage on the car. Yeah, just a bit of wheel arch also damaged, but this is just thin plastic. Nothing really visible. Do you see anything else? No. Yeah, the seal cover here. So probably again something has scraped underneath. You look, all the plastic fixing there broken. Now, I think at this stage the plan will be to drop the battery and strip it. So we expect it to see two modules somehow split into, since he has two BMS in one. It will be quite an interesting one. But look in here, it was something. See, probably that's when this broke. That's so easy because the seal cover stands out, and you can, you know, clip something. Just looking at the battery, yeah, easily to clip a curb, a higher curb, and then damage this. Anything else visible now? Not really, no? Hmm? Okay, the battery starts. So 52 kilos, 349 nominal, and 80 kilowatts hour battery. Well, yeah, quite a big battery, 231 amperes. because I know those batteries, they have quite a good range. If I'm not mistaken, they should have over 350. I think the Mercedes, the EQC, they have quite a good range. Anyway, saying that, I think the plan is to take the battery off. We're gonna, yeah. Do we have to take the seal covers off? Yeah. Yeah. We have to take the seal covers off because behind them, they are the battery. If you come and film here, we have the mountings of the battery. So we have to put the car back down. Yeah, remove obviously, make the high voltage system safe to work on. Take the service plug, 12-volt battery, take the seal cover off, and then put the car up in the air. Should we take the under tray now, just in case we have to see, might have coolant that we have to drain. So let's do that before. Yeah, because we might need to take the coolant off. It should be coolant cooled. Yeah. So we'll do that. Then we're gonna drop the car and do the other task, and then afterwards we're gonna take the battery down. So we have the battery disconnected from the high voltage system, from the cooling system, and also we have revealed the securing point. So here are the cables at the back that are going to the rear motor, both disconnected. We had to take the seal cover off to reveal the securing bolt. Yes, so the bolts are all across here, which normally are covered by the seal cover. And in the front, we also have high voltage cables and the cooling to the battery. So all been disconnected. Now we are at the stage where we can drop the battery on our new toy. So much easier to work with a hydraulic table like this to drop the battery. And this is gonna be a first. So we also had in the middle some securing bolts which are already removed. So are we ready now, Lal? Yeah. So what we're trying to do, make the platform sit flush on the battery. The adjustment is not enough to lift the platform from here. We're gonna turn the table the other way around. Oh, be tight. I could have dropped it more. Should I drop it more to make it easier? Yeah. Yeah, it's perfect now. So we're ready to disconnect it now? As we are ready to undo the bolts from the battery, it would be a good idea to have the specs on. So 2, 4, 6, 7, yeah? And here, oh my God, this is a big battery. Back side is high. 652, 231 amps. Big, heavy. Yeah, let's go, let's go. All good? Yeah, all good. Wait. You need higher? No, it's down? All good? This is a big heavy thing, isn't it? And the EQC battery now is down. Look at the cooling circuit. So it has quite a lot of cooling inside. So the information that I get about this battery is that it's a battery that uses series and parallel technology. In order to get the range, it uses series and parallel connection. Obviously series because all the high voltage battery uses this, but uses also parallel connection to extend the range, which I said initially is going to be about 350. Is not on this model. So this model by the book, it says it does about 240, but in real life about 210 miles. Now let's see what else we're gonna draw from here. We might end up taking it all apart. We can assess, yeah, exactly. It might be a good point to start with this. But for us to do any work on the battery, this is now going to be moved into a different bay where we're going to start stripping it. Yeah, that's the plan. We have a plan. Now we need to transport the battery to the workshop where we're actually going to work on. This is a heavy thing. Just need to hold it together. A big thing. Slowly. Huh? It's a bit of a journey. Should be all right. And this is the place where we are going to work on the battery. We're going to start with the front cover. Hopefully we're going to find something in here. If not, we're going to go on the back cover. Those, they should be pretty simple. If we have to get more into it, that's going to become more comprehensive. And why? The main reason is because of this silicone, which is so bad. We know from previous vehicles, but let's get it one step at a time. The front cover off. So let's bring up the tools and take it off. How is it sealed? So with silicone, yeah. Okay, well, we don't see much here. So the pyro fuse is there. So in case of a crash, that's one of the pyro fuses. But it's so difficult to access. Look at the amount of bolts. Hopefully we won't be able to get there. Not much to see now, but what I can see, this other cap, the way it's been designed is to have access on 2 bolts. So it makes me think that we should be able to have access to something in here. What we like to do is to obviously do the easy thing first, because the hardest thing is to take the cover off. So hopefully we won't be required to get to that extent. So in case we're not going to find anything in here, we're going to move to the rear cover, like I said. And if nothing is found in there, we have to have the whole lot off. Let's pull the cover off. We have something here. We have something here. Now, is this the fuse that is causing our problem now? Also, after we're gonna find hopefully a blown fuse, maxi fuse, the question is why it blew in the first place. But first of all, let's see, did we manage to reach it so quick? So now we're gonna take the multimeter and we're gonna measure the resistance of this fuse. So the way it works, we're gonna join the terminals, and look, when we join them, if we have this resistance, it means the fuse is good. If there's this type of reading, see, then the fuse is blown. Let's see. So it's not, by the way, so this is resistance. By the way, do you know what this stands for? Lal, do you know what this stands for? This open loop. So we don't have an open loop. We were hoping to have an open loop. The fuse is good. And I was discussing with Lal this. Obviously, this was much easier to get onto, but our error code points toward B. And logically, A is front, B is the back. The good thing in here, the cover is much bigger. The bad thing, it's silicone, so there's no nice cover. So what we're gonna do, we're gonna start cleaning here properly, then we start removing. Yeah, okay. Prepare that. We just gonna cover this for now. We're only gonna leave it like that. Leave it just like that. Yeah. So let's have the other one stripped. Hopefully we found something here. We don't need to resort on opening the whole battery, but if we have to, that's what we're going to do. Let's see. So Lal has cleaned the battery, and now we're gonna apply this substance, which is gonna make the silicone very soft, and it will help us to take the bolts away, and obviously take the cap away afterwards. It's a very good procedure, because otherwise this is very, very hard. We've seen it before. So how long do we have to leave it? 5-10 minutes? 20 minutes, yeah? Okay. In the meantime, here is a leaf battery. Similar, but much smaller. Obviously the range on this leaf, you know what's the interesting thing? This is 62 kilowatts, and they were saying the range on this one is about 240. But the leaf is much smaller comparing to the EQC. Look the difference of the battery. How many kilos does it have, this leaf? The battery, do we know? The leaf?
200, 300.
Yeah.
303.
Interesting.
Jaguar
gasket.
Yeah.
Simple.
BMW.
Yeah, take the cover off. Why is this silicone? It looks, you make it so hard to take off, and then you have to bend the cover. Because the whole idea is to make everything recycling, to be recycled easy, to be repaired easy. Anyway. See about the cooling, man. See how, what map of hoses it has inside to cool. So it has probably like few circuits, but it's interesting why it has so many inputs, no? So many distribution. So we are ready now, pretty much. All the bolts, they've been taken off. We've got the very last section to cut the seal. It's quite soft now, isn't it? Ah, okay. Okay. So it's good. Ah, see? They have this sealant here, so it's not that bad. Hopefully it will be everything like that. Oh, that'll be amazing. Okay, let's see what we have in here. So we're gonna have same set. This is the body control, so the battery monitoring system too, we hope. So the BMS one should be in the front, the second here. Let's take this fuse, hopefully, this. Because if not, but even if it is, why he blew? As we are reading the voltage from the battery. So it's gonna be a bridge. Yeah, let's take it off to see exactly, because try to understand how those battery are linked, because maybe the link between the battery is here. It is possible, isn't it? Halfway. Again, another fuse. Just trying to think whether this is gonna be the doesn't look good. So this fuse is also good, which means the problem is farther down. Can we connect direct to the battery? Yeah, let's do that. So in here we can access the battery monitoring. Same connection will be just one connection, so we'll try to connect the scan tool. I think probably the next call will be to take the cover at the back, but let's scan it one more time. Let's see what test we can do with the tool on. So what we have done here, we have connected on the high voltage battery connector, and we want to get some reading. So this is the Pack 2, and we're assuming the Pack 2 should be at the back and the Pack 2 is in the front. And what we seen here, the Pack 2 is 89% charged.
The total voltage is showing 295.
395.
Yeah, the track is showing maximum voltage 357.
Okay, go to module 395, 357. No, I think that's nominal. Yeah. So when it's fully charged, which now is close to fully charged, that's why you have a. Go back to Pack 1. You need to have the gloves off. So this is 345, and if we look at state of charge, 23%. And we know the error code is in the Pack 2, and then the Pack 2 is charged way over the Pack 1. Now, the exercise is to disconnect, because to me, can you disconnect that? So we're going to disconnect the battery control unit 2. I mean, that's what we believe. So we disconnect one of the battery control units. And this is the module 2. It means the module 1 is in the front. And again, if this is the module 2, we won't be able to communicate with it anymore. Can you try, Laura? Bingo. So the theory proves that we're going to have battery monitoring unit 1 here, unit 2 here, and the link, where is the link? In the center. In the center. So basically those battery, they are connected in parallel somewhere, and I'm not sure why it's so curved here, whether the connection is going to be here, but we know for certain. The next stage is to remove this big aluminum cover in the front, assess the cabling. So somehow those two batteries, they're no longer connected. So we're going to have more stripping. Well, it's not going to be just a simple fuse outside. But the biggest thing is, even when we're going to get to find the issue, is the big question mark. Why? 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 There's more to it, so tomorrow there's another day. Yeah. So this is a very, very tricky situation because we have to take this cover off, and because it's sealed with silicone, it's been a very difficult job. Although after we've undone all the bolts, we have no space to try to lift up the cover. So we have invented something. Let's see if it's going to work out. So we put this bracket here, and the plan is to lift up with some pry bars, and hopefully we'll get the cover detached by the body of the battery. But definitely, I don't know, we wouldn't give a high number on design, a high score on design. They should have think for something, because in here you have the pyro fuse, which has to be replaced in case of an accident. I really see no other means to take this cover off, and I'll be quite curious how the Mercedes does it in the workshop. But anyway, this is the plan. Let's see if it works. So. You hear it, yeah? Your end, no? That's the noise that we're expecting for a long time. Oh my God, this is nerve-wracking, to be honest. But how are you going to replace the pyro fuse in this? I don't get it. If it comes to that, how are they going to do it in a 5G? Okay, now let's. Huh?
Minor heart attack.
You had a heart attack. That was a good noise that we just heard, having the cover detached. So now we're going to take it off, and hopefully we're going to find something in here, because otherwise we have to take the full cover. Ready? Whew. Whew. See, the sealant is not thick, but because of the surface, it's been quite a challenge to take the cover off. We're going to leave it here for now. We're going to leave it here for now. So let's see what we have here. Whew. Where do we start? Where is the fuse? Oh, look, so. Okay, so we have few fuses. We have the pyro fuse. This is the pre-charge relay, as far as I can tell. Will I have the resistor in here? What is it? Yeah, this should be. Trying to understand. This will be probably the pre-charge. Yeah, try to understand where is the link between the front and rear battery. It's quite a comprehensive battery, because, like I said, there are two modules connected in parallel. For the moment, we don't measure all the fuses. Let's see if we have any resistance. So that's resistance. We are looking for an open loop. Hopefully we're going to find one. Doesn't look like here. Pyro fuse. Huh? Got a faulty pyro fuse.
Faulty showing open loop.
Well, it says it's faulty fuse. What resistance do you have on that pyro fuse?
That came constant voltage resistance is showing 300 or something like that.
It shows 300 resistance. Really?
Yeah, right.
Why would you have such a resistance? So can you measure again? That's not okay. This is not okay.
Maybe this reading is
Yeah.
triggering the error.
But let's have a look
check
on
that.
that. I think we have found something. We want to check this other fuse. Oh my god. I'm gonna reach that. Which is deep there. Do you need the light? No? Let's see. As in here we have another pyro fuse and we want to check in comparison. So each battery, it has 2 pyro fuses. No. See? We have a faulty pyro fuse and we don't have to strip the pin cover. Let's check it again when I can't believe it. But then why it went wrong? Because if you'd be a crash, you would expect that both of them they're going to be triggered. No? Measure it again. I think it would be smart to have. Not good, not good, not good. Great. So this pyro fuse is triggered by the SRS system. Now, since the car had no crash and nothing that we really see, the only thing that I can think of is that the pyro fuse has gone faulty, which is very strange, but something did happen. Very strange, because I was asking the customer and he said, since they bought it from auction, it was running, but being a company car, they couldn't tell me precisely when the problem started, but they were saying it was fine at the beginning, and then someone realized that at least, you know, the good thing about it, if this fuse has gone wrong, at least we know it didn't go wrong from something internal, because this is either a wrong command or it's gone off by itself, it's gone bad by itself. If you some fuses like this going wrong, the maxi fuse, you know, there'll be some short or okay, let's take it off. Ta-da! This is a tiny fuse like this. It makes a Mercedes big as this, not to have the right range.
Can we check outside one more time?
Yes, of course. You betcha. Hmm? Where's the? Let's put it back. Get excited for nothing. Let's measure it like that, and then. Have we done anything on it? Then we measure it several times. That's strange. Now the measurement looks good. No man, something is not right when you put.
Something
When you put load on it, it's not fine. Definitely, it's not. Put it again. So now, because we have load, yeah, it shows resistance. It's not okay. And now I'll tell you another test we can do. Take it off with the load.
Battery.
Huh?
Light.
Either that. Yeah, light, I mean, is the easiest test, isn't it?
Yeah.
Yeah. We want to redo the test now with the load on it. And let's see. And what we're looking at is if this should pass the test, whenever you're going to put load on it, it should show 0. If the fuse is interrupted, now I'm just thinking whether the load is big enough. That's the only one way to find out, is it? The load might not be big enough, you know? But let's do the light test. Yeah? This is the load test. Would it be strong enough? What's going on? It doesn't make sense. But the thing is, obviously the load is higher than that. Huh? And so it's very interesting. It's very, very interesting. We should, we have like high resistance open loop nearly when the fuse is on. But when it's off, it shows low resistance as continuity. So something is still not clear in here. We still have to check a bit to understand. Let's go. So just to recap, with the fuse on, the resistance is high, is like an open circuit. With the fuse on, off the car, we measure it and the resistance looks good. We also done a load test with the bulb and it looks okay. So it's very strange why when the fuse is on, we have resistance. And now what we're gonna do, we're gonna do a resistance check but without the fuse. If we're gonna have resistance, that tells us is something else. But we should have now open loop, which we have. Which we have open loop. Hold on, did we measure on? Makes no sense. So I'll tell you what we're gonna do. Let's disconnect this fuse. Yeah. We're gonna check again here if we have resistance. If we still have resistance in here, we're gonna put the fuse back and we're gonna do the resistance check in there. Now with this fuse off, if it's the relay, we're not gonna have resistance in there anymore. Yeah? We're not gonna have high resistance, we're gonna have low resistance as is a closed circuit. Make sense? Strange, huh? Not straightforward, but we are getting to the bottom of it. Put this on a side. Yeah. Let's do. What's going on now? The battery is going back to the car, but it's not yet fixed. We've done some checks and we couldn't really conclude which is the fuse that is triggering this error code. And it's not something I'm very pleased, because I think we should have spent a bit more time when we checked it initially before we took it off, because I was quite certain we're gonna have access to the fuses, but on this side I suspect we're gonna have another fuse block in there, but I want to check, I want to do more checks and I can't do them here. So everything that we've checked here, the fuses, the pyro fuse, relay, they all look good. It's not always as you want. But let's see. I still believe we'll have to take the cover off. But with those checks that I want to carry out now, we should be able to conclude that. So it was a situation where we either took the cover off or we put the one that we took off and put it back on the car. So we decided to do the latter one. So now it's going to be the positioning straight. It's going to be a bit of a tricky one, yeah?
Now here it's okay as well.
Yeah, so if we get quite a few of them on by hand. So we've got everything connected and we are on with the dealer tool. And the reason behind this is that we want to run more tests to understand a bit more about the error code, because we could not find enough information, and obviously the checks that we've done were not conclusive on the battery. And we have to see whether we're going to end up taking the big cover of the battery or whether we shouldn't have taken the battery out in the first place. I hope it's not going to be the case, but it's very strange because the way that this battery is the first time, isn't it? It's the first time that we have parallel and series. So two batteries in one connected in parallel. It's first time. So it is something different from a technicality point of view on this battery. Let's see. So where is our problem? It is battery management system over here. The good thing with this tool is that it takes you to a test plan that gives more information about the car. So let's clear, so we are only left with our resetting the function fuzzy lock. I just cannot believe what happened. We were chasing the error code wrongly because we were focusing on a physical fuse, and what we have in here for this particular error code is a procedure of resetting of the function fuzzy lock. I never came across this, and I wanted to put a dealer machine, but the reason where we went wrong, it was so specific for a fuse, and thinking about it, because we had them in the past blown pyro fuse or maxi fuses, we thought it's going to be something simple like that, but the technology in this battery is totally different. So I'm afraid we have removed the battery for no reason. Well, that's what I believe at the moment. The test plan is showing me there's a procedure to do a reset for this error code. It is quite comprehensive. I need to download some software, send it to Mercedes. I have to get a response back. So we're gonna do this, and then we'll see afterwards. I'm a bit annoyed that I haven't done this before, and I wanted, but like I said, the faulty was so specific. I thought we're gonna get a blown fuse in there. Sometimes it does happen. We might have spent a bit of time for nothing, because obviously we cannot charge the customer, but hey ho, it does happen. Tomorrow we're gonna carry on with this, and then we'll see. Obviously, big question mark. What has triggered this? Hopefully, we'll get enough information from the support to solve this mystery. But for now, I'm gutted, man. Let's see. We're gonna carry on in the morning. I wish I would have left it for the morning. So the next stage on the Mercedes, as we currently stand, is to request support from Mercedes, as we need to get a password in order to perform the reset function of the fuse lock. Fuse lock seems to be a function, from what I've gathered last night, where some functions are password protected, might be safety function. So at the moment it's also not clear what happened, why the high voltage battery is unbalanced, why the two packs are imbalanced one against the other, because each pack, each battery is balanced within itself, but them two separate, one is 20%, the other one is 80% charged. So it's not really certain what have triggered. So from what I researched, it looks like this fuse error is actually an electric fuse error. So it's something new that I have not came across yet. So we're gonna open a support ticket, and hopefully we're gonna get more information. At this moment in time, I'm also not certain whether we have to balance the battery before we are able to reset the error code, but I think we have to get one step at a time, and this is what we're gonna do now. The password is inserted. Anyway, this is a valid password probably up until tomorrow. So let's see if the function is gonna change anything, is gonna reset anything. So let's see. All the conditions have to be met before the continue button is gonna be highlighted. Hopefully it went through automatically. Okay, so it looks like it's going to perform a software update on the battery management control unit. Now, I'm not sure whether this is going to be just a simple glitch, or it has been caused by an actual issue in the battery control unit, in the high voltage battery, and I'll show you why. Look what it says on the last page of the document. If fault code appears, and return the vehicle to the customer. If fault code comes back, then this is something that is going to be very costly. But let's see, one step at a time. So for the time being, we are in the process of doing the programming. It's yet to start. Once this is carried out, we have to see whether the error codes can be cleared out. Obviously, we have to do a lot of other things, but let's see what's going to happen here. Injury seems to be undergoing currently. Hopefully it will go through, because it's stuck at some point and we have to restart it. Okay, key in the vehicle. It's perfect, just want to make sure. Yeah, ignition is on. This is a massive update because it contains several components from the high voltage system. So expecting, oh my God, look, it even says here the total update is going to be about 50 minutes. So fingers crossed, and let's proceed with this. Important that battery voltage, okay, internet, good power supply also for the tablet. So let's hope this is going to fix it. Otherwise, it might be something more comprehensive, but this is where we are. Let's see. In here we have stats about each control unit and the time that it will take for the software update to be performed, and that's why we're getting close to over 50 minutes. So we're gonna monitor it, and then let's see how everything is gonna be afterwards. It was really about 50 minutes. What I like here is to see green. So this is a successful. Now, what do we have to do? So all the programming, battery management system, both of them, they've been updated. Okay, Here is telling me that the software is up to date, which is kind of expected. Okay, we'll turn the car off, we'll leave it for 5 minutes, and then we'll see exactly, because on the dashboard nothing has changed, still 112 miles, and still the message, error message related with, see, 112. Now the ignition in few seconds, that goes to 229. As soon as the ignition comes on, that goes to 113. Not much progress. See what happens in 5 minutes or so, whether all this exercise has made any difference, or we are pretty much where we are at the beginning. We're making some progress in a way that we're learning a bit about it, but let's see where we're getting actually with fixing the car, because this is the most important thing. The battery is now fully secure. All the components on the high voltage properly connected. We have planned the cooling circuits for the electric drive, and we are kind of ready to go in the road test and see what the EQC has to say when it comes to driving. Will it maintain the range that it shows now? Let's see. So we have 219 miles. No more error on the dash. And let's see how the driving is. Having everything ready, it's time to go in a road test, see what the Mercedes is going to do under load, see how the battery is going to perform, and hopefully we won't have the error coming back. So only one way to find out. So far all looks good. Obviously we haven't done many miles, but no error came, and the battery is balanced. A big question mark, why, where everything started from, but it could well be just a simple software glitch. Obviously driving in more is going to confirm that, as we haven't found anything permanent. So probably after we're going to do, I don't know, about 30-40 miles, if everything's fine, I'll be happy to hand over the car to the customer, as there's not much for us we can do. But let's see when we get to that. Did we set up the trip counter to 0? No. Hold on. So we reset the trip counter to 0. I think we only done about 2 or 3 miles, so aim to do about 30-40 miles as a pretty conclusive test. So if no error come within this space of travel, we'll hand over the car. So 6.87 miles. Battery looks good so far. Range still stays there. No warning lights. We're gonna do a road test on the motorway, but it does look good. Follow the instructions. So we put a few miles, then we take it in even longer drive test. Everything seems to be good. Battery starts all look good. We received the under tray, we received the seal clips, and we are securing everything now back. Lali's doing that, yeah. But the EQC is now ready and is going to go to the customer. Very interesting thing, why this EQC end up in this situation, but as it stands, we cannot see an issue. So basically we kind of fix the EQC without any real parts. It wasn't easy and more comprehensive because we went a bit sideways due to the error description. Obviously, if we were doing things differently, we probably could have avoided taking the high voltage battery off, but we've done so. We can't change anything, only probably for the next job. But hey, that's how it goes sometimes, you know. We're not perfect. We try our best to minimize the time that we spent and follow the right step, but sometimes it happens. More important is that the car is fixed. And it's going to go to the customer to monitor. Anything comes back, obviously we'll have to have it back, but as it stands, we see no reason to keep the vehicle longer here any longer. And our important bits, what was the cost of this repair? Interestingly enough, no parts at all. Obviously a part of clips and the undertray, but not related with the repair, because everything that it was a software update that has cleared. So we had to remove the high voltage battery. Where we done some checks, obviously haven't found anything. And it's one of those situations where for this, the charge for this is going to be 0, because it should not have been done. Again, it is what it is. So basically, it was a step of investigation, trying to find out which route we go, and we should have spent more time initially. We haven't, but anyway, I already said, this is the situation now. What we're going to charge for that investigation, we're going to charge 360 plus VAT. In the end, we noticed it was a procedure of resetting, then reflashing, then software update. It's quite a bit of things. Afterwards, extensive road test, obviously, to conclude everything. So for this bit, which it was to reset, software update, it was quite a lengthy procedure. We're going to charge 500 plus VAT. So this is going to take us to a total of 860 plus VAT, obviously plus the undertray. So this was the job on the EQC, where for some reason a glitch in the high voltage system has halved the battery. If you remember, so this battery is made basically out of 2 batteries. One of them was not working, therefore the range was half. So the car is ready. It's going to go to the customer. And if you like the video, don't forget to subscribe, click the notification button, because every week we have videos with repairs from the workshop. Thank you, and I will see you next time. Post-repair update. As it's been more than a week since the car is with our customer, we found a bit more news that we did not have before. So yeah, the story with auction apparently is still there, but there's more to it. So it looks like the car had an accident, and after we finished it, we also seen one of the headlights was replaced, and we had to configure that. But we've been told the problem with the range was inspected also by the dealers, and a diagnosis was made, and a repair cost was given. And this is a whopping £56,000, which was for the replacement of the high voltage battery. Now, obviously, you already seen there was nothing wrong with the high voltage battery, was other than the software, which we did. So if we put it in perspective, I think we saved a lots of money on this repair. You already seen the value. So it's £1,000 as opposed to £56,000. And the other thing is, it did not need replacing. So the customer was very, very happy to have the EQC. Again, it's done a few hundred miles on it, operates all fine. So it looks like, if I'm putting everything in line, the fusee lock might have actually come in when the accident happened. So I don't think when the car was purchased from auction, it had the full range. This is my assumption, trying to put everything together. And is very strange, because if it's an accident, normally the pyro fuse would be triggered, but in this situation it didn't. So it could well be because of the severity of the crash. It might be, we don't know. We're gonna find out whenever we're gonna find one. But for now, the EQC is back on the road for a fraction of what was estimated elsewhere. So quite interesting one. What do you say? Leave me a comment.